So in this video, I'm going to be covering all of the basic rules you need to do well in SAT geometry problems. You may be thinking, why would you want to watch a video on the basics? But here's the thing. These basics are the stuff that appears in every single SAT geometry problem. In fact, if you don't know this stuff, it's literally impossible for you to do well in SAT geometry because you're going to see so many things you just won't know how to do. In fact, if you've watched the other videos I've already posted on different geometry concepts on the SAT, you would notice there are a bunch of different things where I say, okay, this is just a basic geometry concept, or I will talk about this in another video. And those are the exact things I'm going to focus on in this video. So if you've ever been confused with one of my other videos, this will explain all of that. So in this video, I'm going to explain all the basic rules you need to know for SAT geometry and how to actually use it in practice. If you want to know why you should trust me, I've personally scored 1550 on the SAT. I own the largest SAT Skool community, and my goal is to make the channel that you're watching right now the best SAT YouTube channel in the world. I'm recording this video at 11 p.m. at night, and you guys know how much I love sleep, so you can tell I'm serious about making the videos on the channel good. Okay, on to the actual stuff here. So the first thing you should know going into this, I kind of hinted at this already with the intro, but basically the way you should think about this is you really need to know this stuff for all of the geometry questions. If you don't know this stuff, it's kind of like if you're trying to learn physics, but you don't know basic math. It doesn't matter how many different physics textbooks you look at, you're always going to be absolutely cooked because you won't know just how basic math works, which is what all of physics basically relies on. So you must know this stuff. I'm going to give you a bunch of different key rules to know for SAT geometry, and then we're going to go through some practice problems on it. Okay, the first thing you need to know for SAT geometry problems is this rule with two angles on either side of each other. A lot of SAT tutors say, okay, this is like the vertical angle rule, this is the complementary angle. I really don't care about any of that stuff. All I care is that you actually know what it looks like and how to use it. It doesn't matter if you know the exact name of it or not. It really does not matter to me at all. Okay, so just to get something out of the way, what an angle is basically the distance that two different lines can be spread apart from each other. So for the example, this one is a 40-degree angle. The unit for angles is the degree, like degrees, like Fahrenheit, but not like that. Degrees in a different kind of way here. If you've ever used a protractor, you should definitely know what an angle is. Okay, if you have two angles like this that are just on the exact opposite of each other, and you have two lines that are just perfectly crisscrossing like this, these must be the exact same angle. This is the simplest possible geometry rule, but it makes everything else so much easier. What you can't have is something where like one of the lines is like bent in the middle. So if it's something like this, then of course this angle would not be the same as that angle. You can tell just by looking at it, this one is much bigger than that one. But if they are exactly perfect like this, they're both straight lines, then you can use this. In addition to that, you can know that whenever you have a straight line like this, the angles on it must add together to 180 degrees. So if you are somewhat good at math, you would know 40 plus 140 equals, you guessed it, 180. And that makes sense because they are both on this line. So if you have a line like this and just any kind of angle coming off of it, you know these added together must always be 180 degrees. Same thing for over on this side. I just wrote all of them so you can see every single angle over here. Now, in addition to this, you can have a situation where you have one line passing through two parallel lines. When I say parallel, what I mean by that is that they basically are just perfectly matched up. So this line is the exact same angle as this line. They are both just perfect on this. Hopefully you know what parallel is, like parallel parking. If you have a car and you have the curb like this, you're trying to park the car basically in this configuration to the curb. You would not want to be parking like, this, as I sometimes do because I really am bad at parallel parking. So that would be not parallel and this would be parallel. So if you have two lines that are like that and you have one line going through them, you know these two angles must be the exact same as well. You can kind of just logically tell this, like, yes, these look pretty much the exact same angle, but it's actually also true based off of geometry. And then the final thing is kind of bringing all this stuff together. If you have two parallel lines and you have a line going through them, you would know that these must add together to 180. These must also add together to 180. But in addition to that, you can take this angle and say it's the exact same thing as this angle up here. These both must be 70 degrees. And likewise, these both must be 110 degrees. The thing to know about all four of these things is that it just always must be true. Many people are confused with geometry questions, whether they can make, an assumption, whether they can assume that this angle is what it looks like. These are the only cases where you actually can make that assumption. You actually can just look at this and say, okay, that angle is the exact same as that angle. It must, in fact, be the exact same measurement. These both look the same. They must be the same. But these are the only times you can do this. You cannot just assume that an angle must be something because it looks like a certain amount. For any situation not described here, you must actually have the angle measurement listed in order to make these kinds of assumptions. Might be kind of obvious, but trust me, many students, it's not that obvious for. Just trust me here. Okay, now onto some shapes. What a shape is, in case you skipped preschool, I guess, is a group of lines where they're all enclosed. We see here, this is a triangle. If it was not enclosed, it would look something like this. You can see there's this big hole at the top. That would not be a shape. Okay. Big thing to know with triangles is, first of all, when you have the interior angles of the triangle, aka the angles on the inside of it, they must add together to 180 degrees. Very, very simple here. But one thing you may not realize is that this is also a rule for other shapes as well. For example, if you have a square, something like this, and you're trying to find the amount that the interior angles of this must be equal to, you can use this exact formula, 180 multiplied by n minus 2. In case it wasn't obvious, n is the amount of sides of the shape. And so you can use this formula on literally any shape imaginable to figure out what the interior angles must equal to. If you want to confirm it on this triangle here, just think about it. The triangle has 1, 2, 3 sides. 180 times 3 minus 2 would equal 180 times 1. 180 times 1 is equal to, you guessed it, 180. I know this must be completely mind-blowing to all of you. Likewise, if you were to look at a square, it would be 180 times n minus 2, 180 times 4 minus 2, because there are 4 sides to a square. 180 times 4 minus 2 would be 180 times 2, which would be 360 degrees. And you guessed it, yes, if you add together the interior angles, 90, 90, 90, and then also 90 up here. So it must add together to 360 degrees. If we even have a shape here like a pentagon, pentagons have 5 sides. We could do here 180 multiplied by 5 minus 2. That'd be 180 times 3, which according to Desmos is 540. So if you add everything here, you get 540 degrees. Okay, I know for some of you, this was like the most basic, easy stuff imaginable. Let's just go through a few more rules and we'll finally get to some good practice problems to test you on this stuff. In addition to that stuff, another thing I must tell you is that when you have an equilateral triangle, aka a triangle where all the sides are the exact same measurement, you must have the same angle measurements as well, which would just be 60 degrees, 60 degrees, and 60 degrees. Because if you divide 180 by 3, it must inherently be 60 degrees. So just know this, equilateral, same sides, but also the exact same angle measurements in every single part. You can also, though, have an isosceles triangle. This is where these two sides are the exact same, but this one is something different. When you have an isosceles triangle, these two angles over here must also be the exact same, so they can both be 80 degrees. So if you know just one of these angles, you know what the other one must inherently be as well. And one more quick small rule, if you have the exact same angle measurement, these would be considered congruent angles. I talked about this a little bit in my similar triangles video because this also has a really important thing with that. But yeah, same angle measurements means congruent angles. That's just the term for it. And then just finally here, we have exterior angles. So if you have a configuration like this with a triangle and then one line just jutting off from it, you know that this angle must equal these two other angles added together. C must equal B and then also A. Also just surprisingly useful in some random problems. Big thing to know here is that C is not equal to this angle. This one is completely not important, not useful at all, but you can know that these together would add up together to 180 degrees according to that rule above. But besides that, this one is not important. You just look at the ones that are not right connected to that angle. Now, I'll be real, I can definitely imagine some of you watching this video up until this point and think to yourself like, bro, we know this stuff. Like, we know that this is how this stuff works. You're not giving me any new information here. And yes, I completely agree with what you're saying. For many of you, this might not be new material. But before you fully say that, just make sure that you can solve these questions, because I have talked to many students who maybe would have told me that they understood everything I went over here, but then if they get shown a question like this, they just suddenly have no idea what to do. Because with a lot of these SAT geometry questions, what happens is you're getting some kind of weird configuration like this, and it's kind of like a puzzle. Like, you get given these different pieces of information, and you have to figure out what can you do with the unknown stuff like this JKL here to figure out what the answer would be. And oftentimes it just comes down to playing around with stuff, just seeing what works where, trying it out, and just seeing when you can find the right answer. You may think that there's a much more complicated thing than that, but that's honestly just how I solve these problems, so just follow this exact thing. Also, what's going to be important here is writing equations for a lot of this. We went over some examples where, the angles must equal, for example, 180 degrees or just equal what the other one is. In these cases, you can just write, for example, 140 plus, let's say if we didn't know what this one was, we could just say 140 plus x1 equals 180. That would be a potential equation you could write for these problems. And so I'm going to be writing a lot of those with these. Okay, enough talking about this. Let's actually go ahead and solve this problem. So we have here, we're trying to find what JLK is. All this information is just describing what we have here. So pretty easily, we can just see here that we have this thing, and that thing. They must add together to 180 degrees because this is a triangle. So I can do 45 plus 2x plus 5, parentheses on that, just in case, plus y. I'm going to use y to describe that one, and that must together equal 180 degrees. Okay, so that's pretty good, but if you've watched my other videos before, you would know you must have the same amount of equations as you have variables. We have here two variables, but only one equation, so we need another equation somehow, or else we cannot solve the problem. So an easy one we can do, we see this straight line over here, so therefore 4x plus 20 plus y, which is what JLK must be, would just equal 180 degrees as well. This is the other rule with the straight line and then the angle coming off of it. Unbelievable stuff we have here, that the thing must be 100 degrees, which yes is the right answer. We know that it's 100 and not 15 because we're looking for y here, which is what JLK is. See if you can solve this one. I'll admit some of the angles and the thing that went with them got kind of cooked, so I just drew these lines with them, but everything else is pretty simple. Okay, big thing that may jump out at you here is we have two parallel lines. And so you're probably thinking back to these rules I went over here and over here. And yes, we do have to use those rules. So think about this for a second. We have, wait, not that one. We have this whole big angle here, which is 132 degrees, and this smaller one, which is contained within the bigger one, which is x plus 8. We also have this angle, which is 3x plus 4. If you think about it, though you kind of have to contort your head a little bit to see this, what this basically is just two parallel lines and one line going through them. That is basically what is going on here. So with that information, we know that this angle, specifically this one over here, not the entire thing, would be equal to this angle. It's basically like we have two parallel lines, and then we have this A to D, which is going through them like this. In this case, this angle would equal this angle, and then this angle would also equal this angle. So let me just go ahead and write some equations. We know this whole thing must be 132, but we don't know what this angle specifically is. In order to find that, we could just say 132 minus this annoying x plus 8. So now we have just this angle BAD. And then that must be equal to 3x plus 4 because we just have this angle over here. Since there's only one variable in this, I can just put 1 and 1 and then just put a tilde, and that gives me the answer being 30, which yes is the right answer. 3, so we have some other stuff here. First thing we can very clearly see is this is a triangle, so 180 degree rule. We can just say here 3k plus 10 plus 55 plus w would be equal to 180 degrees. But again, we have two variables here and only one equation, so we need another equation in here somehow. You can probably tell this is going to involve the 180 degree rule when you have a straight line. So we have here that 7k minus 5 plus 55 plus this random angle over here would add together to 180 degrees. Now, what would be this random angle over here? Well, you can probably tell based off what I've been explaining so far that you have to use this parallel line rule again. And so using the parallel line rule, you can imagine it's kind of like this, and you have two parallel lines here. Again, I know they don't look exactly parallel, but that's fine. And so in that case, if you imagine this thing would be like over here, this thing would be over here, and those would be the exact same angle. So therefore, we can basically just say plus 3k plus 10. That is what this angle is. It's just this exact one. And that must equal 180. As you may know, if you know anything about Desmos, you do have to use x and y when you're writing a system of equations like this. So I'll use x for k and then y for the w. So x there, x there. We get this kind of configuration, 12 and 79. 79 would be the right answer because we're looking for w here, which is my y. So therefore 79. Okay, moving right along here. So let's get rid of some of the parallel stuff and talk about some of the other rules for a second. So this is a very sneaky problem, I will be honest, because there's a few things that kind of feel like trick questions here. The first of those is the fact that you have y here and z. So this literally just be the exact same angle. Like the rule still applies here, even though they're trying to make you feel like it's something different. So we just know that this has to be y. So okay, we avoided their trap there. It just is y and y again. Second thing that you may notice if you look at this hard enough is these are both isosceles triangles as shown by these two hatch marks in each one. They are the same side measurements for each of these and each of these. Therefore, the angle measurements at the bottom must be the exact same as each other. So this would also be x. But, you know, just think about it again, this would also be y. So therefore, this triangle is basically the exact same, or at least it's similar to the other one. So these would also be x and x because they must add together to 180 degrees. So if we know that these are the exact same and this is the same angle as there, we know it just must end up being the same measurements. With this information, it is very, very easy to just write a couple of quick equations. First one here, 2y equals z plus 30. We know that z is equal to y, so we can just say 2y equals y plus 30. Amazing. Technically, we could just use that to solve the problem, but I'll just go ahead and write another equation regardless. So y plus x must also equal 180 with the triangle rule. So therefore, we see here 75, 30. So the answer would in fact be 75. because that's the x value. Just a quick thing that I should mention, the isosceles rule is one of the sneakiest things on the SAT for the geometry because it never really jumps out at you and it's just like a thing that can sometimes show up. Like they just randomly say, oh, this is isosceles, and you have to just remember, oh wait, you have these same angle measurements here as well. So just keep that in mind. It's something that many students miss the first time they go through a problem like this. So, okay, we have some more triangles here. So we have these two intersections over at this point E, and then we're trying to figure out what x would be. So you can probably guess what I'm about to do here. I'm just going to set a variable for this thing here, and it would be the exact same variable for both. Okay, pretty simple stuff there. In addition to that, we have an isosceles situation again. Again, probably did not jump out at you as first unless you really are thinking about isosceles now, so keep that in mind. Good thing to know. 58 degrees would also be the measurement over here. With this information, we have more than enough to solve the problem because we can just say here y plus 58 is equal to 180 for this thing over here. Just put y1 there instead and tilde, so we get 64 would be equal to y. But that's not what they're asking for. They're asking for x. So we know that this would be 64, and we can then write 64 plus 47 plus, I'll say x1 regardless, equals 180. Therefore, x would be 69. Good stuff there. Last problem for this video, we have here two triangles yet again, and we have some parallel information, that kind of stuff. We can just know here, first of all, that this would also be x, and then it's actually literally that simple. We can just say x1 plus 42 plus 53 would be equal to 180. Kind of shocking it's that simple, but yes, it is. As always, if your current SAT score is less than 1400 and you're trying to get it to above 1400 by your next test and you're tired of just doing random practice problems, check the link in the description for Mission 1400 Plus. What you get in here is my full SAT math and reading and writing course, plus a ton of other resources, including 28,000 practice questions, one-on-one support from me, and actually a chance to be tutored by me myself. Yes, every student in here has the ability to access tutoring because we do so with a credit system where you can actually study, and the reward for studying is tutoring. Bunch of awesome stuff in here. Would really recommend giving it a shot if you can before your next test. Check the link in the description for it below. Good luck on the SAT and make sure to always stay Gucci.